Okay, so you guys may have had some experience factoring. How many have had experience factoring? Remember doing it in the past? Okay, some of us do, a lot of us don't. And the way I'm teaching you today is going to be different than the way you probably learned. It's going to be, remember, in math there's shortcuts, and shortcuts are good because they're quicker to get, especially when you have really complicated problems and a lot of stuff to do. You want to take shortcuts, but before you take the shortcuts, you want to slow down and make sure you understand why do they work. And so right now we are doing factoring the way that explains why it works. And eventually we'll get to problems where factoring is not the focus, but we'll need to factor, and we'll probably start taking some shortcuts. Okay. So I want you, for right now, even if you know how to do these a different way, I want you to use it this way. Okay. So the first type of factoring is to factor out a GCF. So you look at all three terms. We're going to do number 6 together right now. Is there something that all three terms have in common that we can factor out? Other than 1 or itself, yeah. So no. Then second type of factoring is what we did yesterday. If you have 4 terms, or an even like 6 terms, or an even number where you can split it in half. We don't have that. We got 3 terms, odd number, right? So we can't factor by grouping. So now we need a third type of factoring, and so that's what we're looking at here. So the first thing you do is play a little game, and I'm going to draw an X here, and I'm going to ask myself, what 2 numbers multiply to 3 times 12, which is 36, and add to 20. Now let me show you where things are coming from. The 3 and the 12 are your leading and your constant coefficients. Your 20 is your linear coefficient. Okay. So you're using all 3 of those numbers. So you want to multiply the first and the last number together, and you want to just think about that second number. So can we come up with 2 numbers whose product is 36 and whose sum is 20? Cody. 18 and 2. Right? So 18 times 2 is 36. 18 plus 2 is 20. Right? Does it work? So if it works, then that tells you that this method's going to factor. If this doesn't work, then it tells you it's not going to factor using this method. Okay? So this is kind of, once you get this far, then you know everything's going to work out fine. So once you have the 18 and the 2, that's going to split up your middle term. Right now I have 20 D's. I'm going to split them up to 18 D's plus 2 D's. So it still adds up to 20, but I'm splitting it up in a specific way coming from the 18 and the 2 that we found here. So 3D squared plus 12. I'm going to bring my first and my last term down. Everybody okay with that? Now what we've done is we've created 4 terms instead of 3 terms. Now, does anybody have an idea what to do? Yeah, do what we did last night. So now you can factor by grouping. So these 2 terms factor out of 3D. What's left? What do you get when you factor out 3 terms? D plus 6 plus factor out of 2. And what's left? D plus 6. And now both terms have a common factor of D plus 6. So factor out the D plus 6. And you're left with 3D plus 2. Okay. And that's our answer. And we're asked to check it. How are we going to check this? Yeah, Kiki, hand up. So I split the 20 to 18 and 2. So I'm well, it's a common term. What is 18D plus 2D? It's 20D. So I have to keep the D's there, right? So I'm just splitting them up. But yes, that's where they're coming from. So for when you're checking, you got to take your answer D plus 6 and 3D plus 2 and multiply that out. And go ahead and multiply that out and check your answer. So did it work out okay? So compare your factoring work with your checking work, and notice that the last line over here is the first line over here. The second to the last line on your factoring is exactly the second line here, right? Or the third line, second line. The second line here is the third line there. The first line is the last line. So it's exactly in reverse order. Okay. So let's try it again on number 8. I'm going to skip some. What I skipped is homework for you, okay? So 8, we're going to start by seeing if it factors. We're looking for two numbers that multiply to what? 3 times negative 40. What's 3 times negative 40? So it's got to multiply to negative 120. And it's got to add to negative 7. So see if you could figure those out. How many found this problem a little harder to come up with than the last one? Okay. So eventually you'll encounter a problem that's just like, I don't know what two things multiply to this and add to this. And it's nice to have a little strategy to figure out what two numbers multiply to 120. Obviously, it's 12 and 10 because you got a 0 at the end. It's even, so 2 times 60 could work. But what else? What else multiplies to 120? And so if you're just having trouble coming up with things from the top of your head and it's not so obvious, what I do is I take the 120, I ignore the negative for right now, and I break that number down to primes. So 120, for example, is 12 times 10. 12 is 4 and 3. 10 is 2 and 5. 4 is 2 and 2. And so I know 120 is 2 times 2 times 2 times 3 times 5. Those are the prime numbers that make up 120 and also make up all the factors that multiply to 120. So if I group these factors in sets of 2, I will get all that I want. So for example, I can group that way. If I group that way, then what's 2 times 2 times 2 times 3? So that's 24 times 5. All right, so that's an option. 24 times 5 is 120, so I could use those two. And you try it out. Is there any way to make 7 from 24 and 5? If I subtract them or add them? No. So then okay, let's try grouping it a different way. I got 3 2s, a 3, and a 5. Let's try this way. Well, what's the 3 2s? 8 and 15. Well, if I add those, I don't get 7. If I subtract them, do I get 7? Yes. So 8 times 15 is what we want to work with. Now we want to think about what should be positive, what should be negative. Right? I know I want a 15 and an 8, but which one should be negative? 15, right? Because you have your answer is negative 7 when you add them, so you want the bigger number to be negative, so that when you add them, you get the negative 7. Okay. So this trick of getting your prime factorization and then just grouping them into two groups, and you could rearrange them. So you could also do something like this: 2, put 2 at the 5, and then I got 2 more 2s and a 3, and that would give me what, 10 times 12. And we know that one, right? But you don't have to keep them in order from lowest to highest. You can rearrange them to come up with the factors. Okay, so that's a good thing to know, especially when you're struggling coming up with the two numbers. All right, so we found them. So then the next step is to split this up to negative 15p plus 8p. And then we carry down the 3p squared and the negative 40. So we expanded it from 3 terms to 4 terms. Now we can use our factoring by grouping. So what do we factor out of the first 2 terms? 3p. What's left? P minus 5, good. And then last 2 terms we could factor out a 8, and we're left with another p minus 5. And then both of these have the same factor, p minus 5, so you factor that out. Oops. So p minus 5 times 3p plus 8. And then again, you got to check that. And I'll leave the checking for you for homework, okay? So let's try number 10 now. Give number 10 a chance. Numbers are getting bigger. I'll give you a 30-second head start. So when the numbers are really big, look for one thing here, because sometimes this is a trick that you want to look for because it could happen, and it does happen quite a bit. Look at the first number and the last number and check if they're, well, anybody notice what they are? What kind of numbers they are? They're both perfect squares. So if you notice the first number and the last number are perfect squares, almost always this trick will work. Not always, but almost always. So you start the same way and saying, okay, what two numbers multiply to 4 times 81? And I'm not going to even multiply them out. I'm just going to leave it 4 times 81 and add to negative 36. Well, 4 times 81 are both perfect squares. So 4 times 81, 4 is 2 times 2. 81 is 9 times 9. And so if you pair them up, you kind of split them up. So I take one of the 2's with one of the 9's and the other 2 with the other 9. what is that? What product will that give us? What times what? 18 and 18. And just check, if I add those, do I get 36? And usually it works like that. If you have perfect squares, that's a trick that you can use. And it doesn't always work, but if it does, check that one first because it'll save you some time. So 18 and 18 is what I want, but I can't, something wrong still. How do I fix this? Yeah, you got to make them both negative because the product is positive, so I need a negative times a negative because when the sum's got to be negative, but the product's got to be positive. So I know both terms are going to be negative. So then you split them up, negative 18x and another negative 18x. Bring down the 81, bring down the 4x squared. Factor by grouping. So the first two terms I could pull out of 2x. Left with 2x minus 9. Last two terms I could pull out a negative 9. Left with 2x minus 9 again. Both terms have the 2x minus 9. And we have another 2x minus 9. And so we have matching factors here. So if you have two factors that match, what's the shorthand for writing that? Yeah. That's the same thing as 2x minus 9 quantity squared. And that would be our answer. And again, you're going to want to check that, and I'll let you check that for homework. You check by doing what? What? Which is? What's the opposite of factoring? Multiplying. Good. Okay. Now let's scroll down to the very number 15. 15 looks a bit different, right? It's something to the 6th power, not to the 2nd power. So it's not quadratic, it's the power of 6. But our factoring techniques are not limited to quadratics only. And so number 14 and 15 are not quadratics, but there's still 3 terms. And so we could try our method on this. We just have to change a couple things about the method. So let's do 15 and see how things may have to be adjusted. So we still start saying what two numbers multiply to what? One times negative 32, which is negative 32, and add to what? Negative 4. So find those two numbers, however you'd like to find them. Let me know when you have them. Okay. Negative 8 and 4. Do you agree, Lindsay? Okay. So now when we split this up, what am I going to write here? Negative 8 what? R to the 3rd plus 4 what? R to the 3rd. So what's important here is that these two are always like terms with the middle term. So this is an R to the 3rd term, so both of these have to match it. And if you go back and look, the two middle terms always match that middle one in the trinomial. And then we bring down the negative 32, we bring down the R to the 6, and then factor by grouping, and everything else is going to work out perfectly. So it's just that adjustment, just so you know that when you split those up, they have to be the same kind of term as the term that's being split up. So when we factor this, what can we factor out? R to the 3rd, and we're left with R to the 3rd minus 8 plus, second one we could factor out a 4. We've got an r to the third minus 8. And then we could factor out the r to the third minus 8. And we're left with r to the third plus 4. And at this point, that's where you'd stop. But the r to the third minus 8 will factor more once you know how to factor a difference of two perfect cubes. Haven't looked at that yet. This one won't factor anymore, and we'll have to learn why later on. But this is as far as I'd want you to go right now. And so then you can check that. Okay. So that's the new kind of factoring. It's really how to split something up from 3 to 4 terms so that we can use factoring by grouping. Let's do a solving problem together. I'll let you pick one that we will do together. 16, 17, or 18. Your pick. 17? Okay, I heard 17 first. Let's do 17. So you tell me, 17, what do we have to do first? Why? Okay, we want to make the equation equal to 0, so we're going to have to subtract 30 from both sides of that equation. And we get c squared plus c minus 30 equals 0, because we want to use the zero product property, so it's got to be equal to 0. Okay. Then we factor. Looking for two numbers that multiply to 1 times negative 30, so that's negative 30, and adds to 1. What is it? 6 and negative 5. So we split it up. C squared plus 6c minus 5c minus 30 equals 0. And then we continue what we've learned. So we factor by grouping. All right, so now it's factored. I wish I had a little more space, but now that it's factored, what do we do? We have our a times our b equals 0, which means what? One of them has to equal 0. So you split your factors up. I'll do it over here. So either c plus 6 equals 0 or c minus 5 equals 0. If c plus 6 is 0, then c is negative 6. If c minus 5 is 0, then c is positive 5. We'll stop there.